Okay, this is a video lesson to help finish section 2.3, instantaneous rate of change, which remember is equal to the value of a derivative, which means the same thing as slope of the tangent line. So those are three big topics that we're talking about in this lesson. And in this lesson, we also discuss the power rule. So the power rule, one more time, just so we can remember, if given a function and its form is c times x to the r power, the derivative, the instantaneous rate of change at a value x, is c times r times x to the r minus 1. Okay, so for this video lesson, which is also going to work some of your homework, you will need a calculator because you're going to use the vars and y-vars, and your book, and these notes, which we started on in class, and block C. I have not finished this last page with you, so I'm going to talk about a couple of problems from this section because it will help you with your homework. So let's start with this last page of your notes. And you have f of x equals 8x minus x squared. It says find the slope of the tangent lines at x equals 2, x equals 4, and x equals 5. So remember, slope of the tangent line equals the value of the derivative at that point. So let's find the derivative using the power rule. So that'll be 8 minus 2x, and the value of the derivative at 2 is 8 minus 2 times 2, which will be 4. The value of the derivative at 4 is 8 minus 2 times 4, which is 0. And the value of the derivative at 5 is 8 minus 2 times 5, which would be negative 2. All right, so there are my slopes. Then the next thing it asks for is to find the equation of the tangent lines. So I'm going to get some extra paper to write out the equation of the tangent lines. And the equation of the tangent lines, we're going to use point-slope form. And point-slope form is y minus y1 equals slope times x minus x1. All right, so I'm going to put blanks for the letters that need to be numbers. So y minus blank equals blank times x minus blank. So I need to find a value for slope, an x-coordinate, and a y-coordinate. So the first one is to find the equation of the tangent line 1x equals 2. All right, so that means I have the 2 to put in here. I need to find the slope when x is 2. Well, that's the value of the derivative at 2, which is 4. So now I have y minus blank equals 4 times x minus 2. Now I've got to find the y-coordinate that matches with 2. Well, when x is 2, its y-coordinate is when I plug it into here to get the value of the function. So if f of x equals 8x minus x squared, f of 2 equals 16 minus 4, which is 12. So when x is 2, the y value is 12. So finishing my point-slope form, y minus 12 equals 4 times x minus 2. Let's do one more. So I want to find the equation of the tangent line when x equals 4. So again, I'm going to use point-slope form. And I'm going to put blanks where I need numbers. All right, so I need a value for which x I'm using, what the slope is at that x value, and what the y-coordinate is at that x value. All right, so I want to find the equation of tangent line when x is 4. So I'm going to put 4 in that blank. And I need the slope when x is 4, so the derivative at 4 is 0. Now I've got to find the y value when x is 4. So going back to the original equation, f of 4 equals 32 minus 16, which then is 16. Okay, you do the same for when x is 5. And it says to sketch the curve, showing all 3 tangent lines. So to sketch the curve, we'll just put a coordinate plane. And we know that 8x minus x squared is a parabola that turns upside down. So I'm just going to sketch a parabola that turns upside down. And at 4, I know the slope, at 2, I know the slope is 4. At 4, the point at when x is 4, the slope is 0. And at 5, I know the slope is negative 2. So then I can sketch in that extra coordinate, extra line. All right, so next on your homework will be some application problems, and it involves the equation for distance above the ground, or distance height above the ground. So the rate of change of position is called velocity. Rate of change of position is called velocity. So position is s of t. So s of t equals rate of change is instantaneous rate of change, which is the derivative, and the name of that derivative is velocity. So when we work in these problems, we're going to talk about it in terms of what the rate of change is. Suppose a sailboat is observed over a period of 5 minutes. The distance in meters traveled at time t minutes. There's my distance equation. Find how fast. How fast means its velocity. All right, so velocity is s prime. Starting point means when t is equal to 0. So here's my distance equation. So velocity is the derivative of the rate of change of position. So that's 3t squared plus 60. And I want to find the velocity from at the starting point when time was 0. So that's 3 times 0 plus 60, which is 60. How fast was the boat moving into 3 minutes? So that means I want to find the velocity when t equals 3. So velocity at 3. So that's 3 times 9 plus 60, 27 plus 60, so that's 87. And I forgot to put my units of measure, so I'm going to put in there now. I'm moving at meters per minute. And let me put it back here on this one, meters per minute. And write a sentence describing how the position is changing at 3 minutes. So you want to say the instantaneous rate of change at 3 minutes is 87 meters per minute. Okay, so now let's move to our homework, because there's 3 parts on your homework. Your homework for this lesson is page 157, 35 through 43 odd, and 47 through 55 odd. So the main comments I want to make for you and start a few of these problems is 35 through 39 odd are mainly algebra based and the power rule. So I'm going to work 2 of those for you to get you started. And then starting at 41 through 43, these are just like an example in your notes. So I'm going to let you use your notes for those. Then starting at 47, that's a velocity question. You have your notes for that. Remember, velocity is the derivative of position. Then 49 through 53, let's change this, let's take out number 55 and just make it through 53, because 55 is kind of a long problem. They're just all application problems. And I've written you some nice notes on how to finish those problems. Okay, so let's start with number 35. All right, so the function given is and I'm going to try to zoom in a little bit, see if I make that a little bit more clear. So I want to find the derivative. The directions are find the derivative. So to find that derivative, I'm going to have to put it in the form where I can use the power rule. Well, with this denominator, I can't use the power rule. So I'm going to rewrite this function in a form that's going to be easier for me to deal with. And I'm just going to break up each part of the numerator with the denominator. So now I'm going to use algebra to simplify. And now it's ready for the power rule. Okay, you're finished. All right, 37 is a little bit more challenging. Because you have to remember you can't have a radical. You want everything as exponents. So let's change the radical to a fractional exponent. Then I'm going to put the numerator in a parentheses and rewrite the denominator as a negative exponent. I'm doing this so I can use the power rule. So now I'm distributing the t to the negative 1/2 to each of these terms. And when you multiply like bases, you add their exponents. So 1 plus negative 1/2 is 1/2. And I just multiply the t to the negative 1/2 to the 2. Now I'm ready to take the derivative. All right, so take down the exponent, multiply by the coefficient, subtract 1 from the exponent, and negative times a negative makes a positive, and subtract 1. All right, so number 39 is very similar to 37. I'll let you work that one without any notes. Okay, next one is 41. Just talking through 41 briefly. For the function f of x equals x cubed plus 2x minus 4, it asks you to find the slope of the tangent line at x equals -1. So remember slope, tangent line equals the value of the derivative at x equals -1. So you're going to find the derivative first. Then you find the value of the derivative at -1. So that will be 5. Okay, and the rest of this question is very similar to the example. All right, 43 is written out pretty plainly in the solutions I've already posted for you on the homework. Let's drop down to number 47. A model rocket is fired vertically upward. The height after t seconds, so this is height above the ground, is 192t minus 16t squared feet. Part A asks for the velocity at t equals 0 seconds. So the velocity is equal to the derivative of position, which is 192 minus 32t. And I got to find the velocity at 0. Means find the value of the derivative at 0, and that'll be 192 feet per second. Don't forget to put the rate of change in there. All right. Number 49. 49 gives you the population is 9,000 plus 500t minus 72 square roots of t. So again, there's that radical, and we can't use the power rule with the radical, so automatically, before you even work the rest of the question, change that square root of t to t to the 1/2. So part A is asked, find the rate of change, find the rate at which the city is growing after 4 years. So that'd be the derivative at t equals 4, so find the derivative. The derivative constant is 0, and 500 minus 72 times 1/2, t to the negative 1/2. So the derivative is 500 minus 36 t to the negative 1/2. Okay, so then I want to find the rate after 4 years. I want to find the value of this derivative at 4. Well, let's just make it easy on ourselves. Let's take our calculator and kind of get accustomed to using this tool for ourselves. Go to your y equals key. Clear out any questions you have in there. Let's type in the equation of the derivative. 500 minus 36t, which your calculator knows is an x, raised to the negative 1/2. So notice that I wrote 1/2 as my exponent. If your calculator doesn't have the updated version, make sure you put your parentheses, your exponent in parentheses. All right, so I'm going to quit this screen. I want the value of this derivative at 4. So that means I'm going to go vars, y vars, enter, enter, and I'm going to find the value at 4, and it's 482. So that's 482, and I'm measuring population, people per year. Okay, so the rest of the homework, pretty much following these formats. Read them carefully. I've already posted the homework, and it is pretty clear.